Hello everyone, welcome to the final video in this series of very quickly put together STK tutorials. So yeah, the paper is coming out soon. All of this code is available from the last series of videos on STK examples. The final thing I want to show is just something I had a bit of fun with recently, which is a generation of host-guest conformer ensembles. So from the manuscript, I show an example of host-guest chemistry. So basically, STK allows you to build something like this, where you have some guest inside some host, and all STK does is set the relative orientation of the guest with respect to the host using three arguments. A vector that describes the starting position of the guest, and this is this orange vector here. A target vector to align that vector to, so this is the green vector, and then a displacement from the center of mass of the host to displace the guest. This allows you to produce almost any kind of relative orientation, and the important thing is that this is a complex of molecules. It doesn't have to be a cage and a small molecule host-guest system. It can be any two STK molecules, and their orientation in space can be controlled. Cool. So what I want to show you, I've developed a code called spin drive for generating conformer ensembles. And what I want to do here is just code up the generation of these host-guest complexes. I want to make an ensemble, calculate their energies, and plot that. I have okay, cool. So let's pick a cage and guest molecule. So let's go to one of our previous examples. I don't like that cage. Let's do I don't want to do a metal cage because MMFF might fail, actually. The force might fail. Let's try it anyway, and if it fails, we'll replace it with a different one. But let's build this cage. So we have that structure. Let's actually optimize it, and with that, let's actually make it a more reasonable cage structure. A more reasonable cage structure for this would be the M6L12 structure. So not M6L12, M6L12 cube. Oh, you can see MC Hammer has not performed very well there. I think we need it to go longer. Num steps is, let's go 2000. Yeah, 500 is quite short. $2,000 is probably too long, but hey, we get a reasonable structure. Cool, so that's our cage. Let's define a guest molecule. Let's go to my favorite random molecule generating code. Caffeine, I don't want to use caffeine again. Let's build, I don't know, something reasonably interesting. That almost, how did I end up actually drawing something that looked like let's just add some this is a ridiculous molecule, but why not? Cool, let's clean that up. Let's information card, get the smile string, copy that. Sorry for the randomness. stk guest equals stk.building block. So we don't need any functional groups. We can now show stk more stk guest. Cool. It looks like that. It's some conformer of that. Okay, so we've got the cage, we've got the host, we've got the guest. Now I want to show, this is stk-viz from the previous video. Let's go back to GitHub. Let's go to my repositories and go to SpinDry, low cost host guest conformer generation. Basically it performs Monte Carlo, and with the only potentials being steric interactions or non-bonded interactions to make sure there's no overlap of atoms, and it uses this to move and rotate the guest. And you can do this either to minimize the energy with a specific energy function, or with the current unphysical energy function, you can just use it to within a second generate, hundreds of conformers, which you can then calculate the energy of, which is what I'm going to do. So this is a basic example from an XYZ coordinates. That's one way to do it. There's also an example specifically for using it with STK, which is here. So we're going to take this code basically. I'm just going to copy from here onwards and then dissect that code as we go. So SpinDry just needs atoms and their positions. So we have cage atoms, and the guest atoms should be stk guest, and then this should be cage 1. So we should have that, and then we need to define a SpinDry host and guest using this molecule in it, where the atoms are collected from cage atoms and stk mol atoms, and then the position matrix is from the stk molecules. So it just iterates through all the atoms in cage atoms and defines a SpinDry atom with an ID and an element string, and a position matrix from that. Cool. So that defines our host and our guest, and we can go print host guest, and I don't remember if the representation tells you anything. Oh, it tells you the number of atoms. That's it. It's just a molecule. We can define the spinner class, which does the host guest generation, with a step size for the Monte Carlo algorithm, a number of conformers, and we also have, if we go to the code, there's more information we can give it. Spinner. We can control the potential function, which is not what we want to do. We can also ask for a number of conformers and a max attempts. So if we go number of conformers, let's generate 100 and go max attempts equals 2000. So this will run 2000 Monte Carlo steps and extract a conformer if that conformer passes the Monte Carlo requirements. If it doesn't pass, then it goes back to the previous position. And once it reaches the number of conformers, 100, it'll stop the simulation. Otherwise, it'll stop once you get to 2000. So it will only try 2000 times. So this is to avoid continuously trying when you're never going to get a new conformer. And then we can iterate through the spinner. So this doesn't run anything. It yields a conformer using this get conformers method. We can print the conformer, its ID, and its potential based on the unphysical potential energy within the Monte Carlo algorithm. We can write it to an XYZ file, but we don't want to do that. We're going to update the cage to have a with its new position matrix, and update the guest with its new position matrix, and that's done here. So now this is taking it to an STK molecule. So it's taking the conformer, getting the host position matrix and updating the cage, guest position matrix, updating the guest within STK, and then using that to make a HG example output to make a host guest complex within STK. So we can go like, hopefully that runs. It didn't. Cage is not defined. That should be cage 1. And that should be STK guest. What we also want is the energy. So if we, so the MMFF energy equals, we'll make that a dictionary. We'll go energies conformer get CID equals, we'll go stko dot UFF, doesn't matter which one, energy, we want to go ignore false, so we get intermolecular interactions, and we want to run get energy of complex mole. Cage not defined. I've also, yep. Get placer IDs. This should be an stk.buildingBlock.init from molecule of that cage, not a constructed molecule. Right, so you can see RDKit is unhappy about the palladium atom. So we'll see what actually comes out of it. And you can see that we asked for 100 conformers, but in the 2000 steps it could only get 37 to pass the Monte Carlo algorithm. So we can firstly look at energies, and we've got a series of energies. There's not really much to tell from that, because I do think that the RDKit has not handled the palladium atoms well, but we can very easily visualize all these conformers, pymol hg conf, and you can see if we show, so the host hasn't changed at any point, and the guest has obviously rotated. Let's look at just one of them. So that is conformer 0, and we can go the last conformer. It's rotated the molecule kind of completely, and it's avoided any steric clash and so forth. And you could use this as input to some further calculation, which these structures require some further optimization, but that could be done with GFN XTB, for example. Cool, so I hope that example is potentially useful, and thank you for listening to this series of tutorials, and if you have questions, the issues on all of the codes, so STKO, STK, all of their GitHubs, we are very active in responding to those issues, so please contact us if you have any problems or questions. Thank you very much.